Hi everybody, this is Miss Cleet. We're going to go ahead and review some of our exponent laws so that we are ready to start this next unit. So the first rule that I want to go through is the zero exponent rule. With the zero exponent rule, any number taken to a power of 0 is going to be equal to 1. So for my example, I have 6 to the power of 0 is equal to 1. For my next example, we have the product rule. With the product rule, we use it to multiply exponents that have the same base, and we add their exponents to combine them. Here in my example, I have 5 to the 9th power times 5 to the 3rd power. I combine it into one term here by keeping the base the same and adding the exponents, so 9 plus 3 to be equal to 12. My final answer is 5 to the 12th power. The next rule is the power rule. I use the power rule when I have a power, so in this case x to the a, taken to another power. In order to simplify it into one term, I multiply the powers together. So in my example here, I have 7 squared to the 3rd power, and I multiply 3 times 2 to get 7 to the 6th power. Next, I have the quotient rule. I use the quotient rule when I'm dividing exponents that have the same base, and I subtract their powers. So in this example, I have 10 to the 2nd power divided by 10 to the 1st power. I subtract the exponents, and I'm left with 10 to the 1st, or I could have just written 10. And finally, we have negative exponents. We're going to see negative exponents in a lot of the problems on the following slides, and so we need to remember that we can always rewrite them as 1 over whatever the exponent was. So let's look at this example here. I have 5 times x to the negative 2nd power, and that's going to be equal to 5 over x squared. Notice how I left the 5 where it is. It does not have a negative exponent, and so it has to stay in the numerator. Let's look a little more closely at the product rule. The product rule says that when we are multiplying the bases, we need to add the exponents. Let's take a look at the first one together. We've got 9 to the 3rd power times 9 to the 4th power. And so to combine it, we add those exponents together, giving us 9 to the 7th power. Right now, I want you to pause the video and try the next problem on your own. I'm going to give you 5 seconds to pause the video, try it, and then I'm going to go through the answer. Alright, at this point, you should have tried it on your own. We're going to go through it together now. We are keeping the base the same here with this problem and simply adding the exponents. And so we get 8 to the 45th power. Now let's take a look at a little bit more challenging problems. We have multiple terms, and each of them has a coefficient here. So my first step is simply to identify the like terms. I've written the coefficients here in purple, and I've written the exponents in pink. We can combine these and rearrange them in whatever order we want because we're dealing with multiplication. And so in my next step, I'm simply moving the 6 over here with the 2, and I'm moving the powers so that they're next to each other. I'm just collecting my like terms so that I can simplify it more easily. Now we're going to apply the product rule to our exponents and combine them into one term. So once we multiply 2 times 6, that gives us 12. And when we use the product rule here to combine our exponents, we are left with n to the 14th power. I rewrote it so that you can see that this is one term. Again, just like before, I want you to pause the video, try this next problem on your own. I'm going to start the timer, and then we'll come back and go through the answer. Okay, let's get started. So you should have first rewritten your terms here. Next, combined the like terms, and finally multiplied them together, simplified, and then used that product rule to combine y to the 3rd with y to the 8th power. And your final answer should be 36y to the 11th power. So let's take a look at our power to a power rule. Whenever you raise a power to another power, you multiply the exponents. And so in our first example here, we are going to just be multiplying those exponents. We get rid of the parentheses, and our single term here is 5 to the 12th power. Again, just like on the other slides, I want you to pause the video for 5 seconds, try this problem on your own, and then come back when you're ready. So again, with this problem, we're going to be multiplying those two powers. We're going to multiply our 6 times 8, and our final answer should be x to the 48th power. Let's take a look at some problems with multiple terms. The key here is to make sure that you are applying the exponent to all the terms inside the parentheses. So all I've done is I've drawn arrows to everywhere that we need to cube. So we're going to simply multiply those powers. So remember, 2 is the same as 2 to the first, so this becomes 2 to the third. And then we multiply here x to the 4 times 3, right? So that becomes x to the 12th power. Our final answer is 8, because 2 cubed is 8, times x to the 12th. So I want you to pause the video and then come back once you've tried this one on your own. So with this problem, we want to, again, do the exact same steps. I just drew the arrows so that you can see everywhere that I need to apply that exponent. We're going to simplify here. So we have 6 squared times y to the 7 times 2 power, which becomes 36, because 6 times 6 is 36, times y to the 14th power. Finally, let's look at our quotient rule. Whenever we're dividing exponents that have the same bases, we want to subtract the exponents. So in my first example, I'm dividing 5 to the 4th by 5. We can rewrite 5 as 5 to the 1st. And so now we're ready to subtract. 5 to the 4 minus 1, which is really 5 to the 3rd. With this next problem, again, I want you to pause the video, try it, and you can leave your answer as a negative exponent. Okay, you should have tried it on your own, and now we're going to go through the answers. Step 1, we just rewrote 3 as 3 to the 1st. We subtracted, and our final answer is 3 to the negative 2nd power. Let's take a look at some of these problems that are a little more complicated with a few more parts. So the very first thing that I want to do here is make it as clear as possible what my like terms actually are. So I've gone ahead and I've color-coded these so that you can see. 2/3 here is going to stay exactly the same, right? Those are just our coefficients, and they are numbers that we can just divide like any other time. Next set of like terms is our x terms here, we have our y terms, and finally our z terms. We are going to apply the quotient rule on every single set of these variables, and we're going to do that now. So first we've got 2/3, we're going to leave that alone. You don't need to worry about the quotient rule because it's just two numbers, right? Next we've got our x term, so I subtracted 2 from 4, and I just wrote it here as this sort of intermediate step. Next, I've got my y terms, so I have -4 minus -3. Even though that number is negative, we're still using subtraction because the quotient rule means we are always subtracting. And finally, here I got z to the -3rd and z to the 4th, and I'm going to subtract those exponents and keep the bases the same for all 3 of them. So I've taken something that looks really complex and I've broken it up into 4 distinct parts, and I'm using the quotient rule on every single part. Once we've simplified, this is what it should look like. We're not quite done yet because we want to move those negative exponents around. And so I'm going to keep the positive on the top. Notice 2/3 stays exactly where it was, the 2 stays in the top, the 3 stays in the bottom as I combine this into one fraction. X squared is positive, and so it's going to stay in the numerator. Y to the -1st power is going to move down into the denominator, and z to the -7th power is going to also move down into the denominator because they were both negative. Notice once we move it down into the denominator, it changes to positive. And so when I rewrite it so that there's no more colors, it's just one single term, this is what I'm left with. I want you to again pause the video, try this one on your own, give yourself a few minutes to do this, and then come back so that you can check your answer. Okay, at this point you should have tried it on your own, and now we're back to check our answers. So my very first step was simply to break these apart. 3n to the fourth can be represented as 3 times n to the fourth, and same with the denominator here, 3 times n to the third power. So when I am going through this again, I want to be thinking about how I can break this into parts. And so I'm going to first divide the 3's. 3 divided by 3 is just 1. And then I'm going to use the quotient rule on the second part here, n to the fourth divided by n to the third. And so this gives me just n to the first power, and my answer is n. That is the end of our video here. I hope that this was helpful and really good review for you of all of our exponent rules. Keep practicing on your own and reach out if you have any questions.